Dear students, today we are going to discuss two heat exchangers. One is 1-2 heat exchanger, the other is 2-4 heat exchanger. Last class we have discussed in detail the construction and working of single pass 1-1 exchanger in the lecture 1. Lecture 2 again we have discussed what is the need to switch on the multipass construction. So this is multipass construction. So we will discuss 1-2 heat exchanger, and these numbers, as I already explained you, suppose here this is a 1-2 heat exchanger. First number always indicates number of shell side passes, and second number always indicates number of tube side passes. Okay, so that is the indication of this number. 1 shell side pass in this heat exchanger, 2 tube side passes. Passes means what? How many times the fluid is passing through the length of the heat exchanger, that is known as a pass. So here number of shell side passes 1. Here we will just see this already single pass, all these are the construction is same only, except the modification of installing a baffle plate here in this. So this is, except this, everything is same as single pass 1-1. So here one baffle plate is kept here, this one. What is the purpose of this baffle plate? This baffle plate is different from these baffle plates. These baffle plates are 25% baffles. This is the baffle plate to divide this entire chamber into two parts. If this is not there, this is completely one part. So for example, this is CA. C indicates cold, A indicates entering. So entering temperature of the cold fluid here. That means cold fluid is entering here. Suppose if there is no baffle plate here, then what happens? All this fluid occupies the complete cross section and enters the openings of the tubes. But now in this construction, baffle plate is kept. So the cold fluid after entering here, it cannot cross this baffle plate. So it enters the tubes only within the range below this baffle plate. So only here, only these two. These are the tube openings. So this fluid enters only through these tubes. Okay. Then after passing once here, so this here, from here to here, once it is, and then there is no place to escape here, so it has to take a turn, the fluid. After taking turn here, these are the tubes available for the fluid to enter. So the fluid enters here and passes in this direction and comes to this chamber. Okay, so after filling this chamber, it leaves like this. This is the opening, the fluid property. Wherever there is space, it flows like that. So it flows like this, flows out. So this is the outlet of the cold fluid temperature. This is the inlet of the cold fluid temperature. So cold fluid enters here and passes through this once, and then again enters this bundle and again passes through this and then leaves. So how many times the tube side fluid is flowing? Once and 2. So the tube side passes are 2 here. 1-2 heat exchanger, tube side passes are 2. 2 times the cold fluid is passing through the tubes in the heat exchanger. Okay. Then shell side passes in this construction. Yes, shell side is same. We have not kept any baffle plate here. So hot fluid enters here into the shell. Here hot fluid is the shell side fluid. Okay. In this design, we are choosing hot fluid as a shell side. So shell side fluid is entering here, then fills up the complete, here flows it like this, and then leaves the shell here. So how many times it is flowing? Only once. That is why shell side fluid is number of passes is 1 only. Shell side fluid is entering here and flowing through this and leaving here. So only once. That is why it is called one to heat exchanger. One is shell side passes, two is tube side passes, 1 and then 2. Okay. So the shell side fluid pass is flow is how like this, it crosses it this baffles 25% baffles. These are, we have discussed it, the necessity of 25% baffles in the last class. So the fluid flows outside these tubes here like this. Okay, so it flows like this. Like this it flows. Now because of this, here cross flow will be promoted. That means shell side fluid crosses the tubes. That's why it's called cross flow. So it increases the turbulence of the shell side fluid. So here what is the concept here? So we have understood what is meant by the number of passes in this. And also 2-4, if you see here, this is the 2-4 heat exchanger. See here, 2 indicates shell side passes. Here one baffle is kept here in the shell. Here it is not kept. Here this is the baffle. Okay. So because of this, what happens? This is the shell side fluid. So shell side fluid after enters here, it cannot go to this place. So it has to take a turn like this here. Okay. So this is a shell side passes. How many times it is flowing? Here once and then twice. Here it is leaving. Okay. THA, THB. So 2 times the shell side fluid is flowing. That is why it is 2 here. Then tube side fluid. This is tube side fluid entry. Here 2 baffle plates are kept here. Here only 1 baffle plate. Because of these 2 baffle plates, this entire chamber is divided into 3 parts. So here the tube side fluid enters here and enters the tubes which are there only in this section. So it flows like this and then it has to take a turn, comes again like this and then like this. So how many times? 1, 2, 3 and then 4. 4 times tube side fluid is flowing. That is because of 2 baffle plates. Here only 1 baffle plate. That is only 2 times it is flowing. So this is number of tube side passes 4. Okay. So this is about the number of passes. Why? What is the purpose? I have explained in the last class in detail, mathematical. That is with the help of equations I have explained. In simple sentences, 1 or 2 sentences, if you recall, what happens here? Suppose cold fluid is entering here, isn't it? If this baffle plate is not there, it has to occupy the entire cross section. But because of this baffle plate, the cross section available for the cold fluid is greatly reduced. Okay, almost half. So because of the reduction in the cross section, the velocity of the cold fluid will increase. It will increase because of the reduction in the cross section. So the fluid now is entering all the tubes with higher velocities. Okay, with the higher velocities. So now in this heat exchanger, the fluid passes with higher velocities. So when velocity is high, Reynolds number increases and hence HI here, we are talking about tube side coefficient. So HI increases and then U naught and hence heat flux Q by A will increase. So the principle here we used is reduce the cross section, increase the velocity of the fluid. So this principle we have used only in this type only for the tube side fluid we have used. Shell we have not made any changes. Okay, that is why the capacity, that is the efficiency of the heat exchanger will increase. So advantage is higher velocities, heat flux will increase, and disadvantage is a little poor heat recovery, means compared to single pass 1 it is good, but compared to 2 4 this is less. This is how we can see, because here cold fluid is entering here, it is flowing like this, and shell side fluid is here flowing like this. See the and you can see the graph here. This is tube length versus temperature. TCA, cold fluid is entering here, and then 2 passes, so 2 lines. So this is TCB. If you recall double pipe heat exchanger, you will have only 1, but here you have 2 lines for cold fluid, because 2 number of passes. So here and then for hot fluid entering here, passing only once, so only 1 line. So this is the graph, and here little means parallel flow also is there in this. That is why little heat recovery is little less. You can see TCB in this graph. If you observe now, TC distance between THA and TCB is more here. In this, TCB is near to THA. When TCB is near to THA, we say that heat recovery is very good. So that is the limitation. So what is the limitation of this 1-2 exchanger is poor heat recovery. This is the limitation. Then 2-4 exchanger advantage is higher velocities compared to this, and disadvantage high delta P. Here if you see why high velocities, cross section is reduced to much higher than this, reduction is much higher than in this. So that is why velocity will become very high here. So here it flows like this with the higher velocities. And shell side also we made changes. There also H0, shell side means H0. H0 also will increase, HI will increase, H0 will increase. So increase in heat flux will be more compared to this. Okay. But in both the types of heat exchangers, that is multipass, we can say, multipass heat exchangers, there is a common disadvantage. What is that? Is frictional losses are high, because whenever the fluid is passing over a solid surface, friction arises. Frictional loss will be there, because for long time it is flowing through this heat exchanger. Frictional losses are high. Whenever frictional losses are high, then pressure drop will also be high. If pressure drop is high, then power consumption will be more here. So like that. But all this high, low, and this is initial cost is more, because it is little complicated construction, and costly also. Initial costs are high here, high initial costs, but one is high, one is less, and on the whole overall cost they will see. Okay, but pumping costs are less only here, operating costs are less. So all this combination, the optimum cost only we see. So this is how this 1-2 and 2-4 exchangers works. Thank you.